Well, good morning, everybody. I really appreciated getting the opportunity to do this. So thank you, Milton. I've learned so much. It's one of those things you think you know something, and then somebody invites you to talk about it, and you think, I think I need to go a little deeper. And I was very fortunate that one of my colleagues, so I'm Shane Tews, I'm at the American Enterprise Institute, and one of my colleagues just wrote a book that came out last week called Chip Wars, about the semiconductor industry. And I'm not even reading it like chronologically. I'm just like picking pieces and like going through it. And it's absolutely fascinating. So Chris Miller's book, if anybody wants to take a look at it, I'm gonna reference it a lot. So I'd hear if anybody wants to see it. So just a little table setting. First of all, I complimented Milton on something that he didn't even know how smart he was, is that there's a whole range here in the Netherlands. When you think about semiconductor chips, you tend to think of East Asia, and ASML was founded here in 1984 in the Netherlands, and the locals are going to kill me on this one. Venhoven? Okay. So they made $5.8 billion in 2021. The most recent statistic I can find is on Wikipedia. They had 67% of the market for just the manufacturing equipment for semiconductor chips. And so I'm looking for a recent data point, totally rabbit holed on that and had to pull myself out of it. But they basically are the creator of EUV lithography, and they expect that market to be $175 billion by 2027. They're not the only ones in the market, but they have a huge hold on it. The two main things you need to think about when you think about chips in this whole industrial policy are the two. We have fabrication plants, which we've heard a lot about, especially with China in the recent decisions by the U.S. government to withhold certain information. And then we have the fabless, which are basically the designs and the R&D manufacturers that then send these items to China. So just some baseline there. A lot of strategic importance as to where they chose to do that, which, taking a step back into history, which Chris does a very good job of. The whole idea around industrial policy really came out of World War II. And one of the reasons why a lot of these things are based in Asia is the idea that we wanted to find a way to bring them into the globalization process. And the idea of giving them something that they could bring into the global, the global program really had to do about cheap labor. And so we're still seeing elements of that on if we can reshore that in the United States. These are our statistics that are interesting to take a look at. But the other thing I found reading this book that I didn't realize is that two of the major manufacturers were the two people who founded them came out of Texas Instruments. So Richard Chang was the person who helped found SMIC, who you recently heard in the news because Apple had to pull back. They had huge plans to use SMIC as their major element in a lot of their most recent iPhone 14 and a couple other things. But he actually was Taiwanese raised, Texas trained, educated in the United States, and then he didn't get the job as the CEO of Texas Instruments and was still very interested in staying active in his early 50s and went to Beijing and got them to fund and create the fabs that are a lot of what we see today. The other one is you've probably heard a lot about, and if you follow this space, is Morris Chang, who is the person who convinced the Taiwanese government to really fund TSMC, which is the real juggernaut in this space. And that brings us to geopolitics. So just some table setting for that. And then let me introduce you to my colleagues. Dirk and I actually, it's funny, this is the first time we've actually ever met. I told him, I said, he's my Twitter friend. I just, I love his Twitter feed. I know a lot of his colleagues over in the United States. And so he was very kind to say yes, he'd be available to come over here. So let me just a quick bio here. Dirk Auer is a senior fellow at the International Center for Law and Economics. If you all don't follow them, they're based out of Portland, Oregon, which is...
I'm even a director now.
You're a director now. Sorry, you need to update your bio online. His work focuses on the law and economics, antitrust. He spends quite a bit of time there and great Twitter feed on that. Emphasis on innovation policy, digital markets, European competition law. He teaches as an adjunct professor at Louvain. Am I going to say that right?
Yeah.
Okay.
Yeah.
My American accent. Yeah, you want to call it that. Where he teaches an introduction to American law course. I'm sure that must be fascinating. And then at the University of Liège,
Liège.
I should have.
That one is very hard
Okay.
to get.
Where he teaches courses on economics and competition law. So I know that's something that we touched on yesterday. And so he will be, joining us in this. He won 2 awards for papers that he's recently written. Should the Asian antitrust law emulate European competition policy? We touched on that a little bit yesterday. And he also won an award for a piece on governing on the patent commons. So these are, I know, things we've had in tangential conversations. And then George, thank you for joining us from Washington, D.C. This was another fortunate thing where Milton, I have a new friend. I didn't know George until this, and then we had lunch on Friday. And I asked George about his background. He's just so fascinating. He started in what he called 2G, for those of us who were working on 5G in 1972. He holds multiple patents. He was one of the co-founders of InterDigital Communications Corporation, which is still on the NASDAQ. He then worked in, and George, correct me, because I want to call it semiconductor, but what was Illinois? What were you doing?
It was Illinois Superconductor Corporation, a different corner of the industry of advanced technology in the chip world.
And the best part is he's telling me all this really cool stuff. And then he looked at me across the table and he goes, "You're still listening." And I said, "This is fascinating." Just really, really interesting stuff. So he is, great to have. And he has quite a few pieces that have been up. One of them he sent was it Discourse? Was your piece that most recently?
Yes,
and he writes for Forbes. So he is a prolific writer in this area around semiconductors. So I guess since the title of this is we're talking about industrial policy, semiconductors are kind of the elephant in the room. I thought we'd start with that, but I do know, since we do have a lot of internet governance geeks in the room, and at least you brought this up yesterday, IPv6 to me is another area where if the ITU gets involved, has that element of an industrial policy that we may want to get into after we have the semiconductor discussion. So Dirk, I'm going to start with you since you're in the room. What are your thoughts on how we're starting to spend just oodles and oodles of money, government money, as well as individual investors?
So I think looking at these problems, it's probably useful to take a step back. And I think there is a theoretical case to be made for industrial policy, but I think there are many, many obstacles to doing that right. So I think the theoretical case, I'm going to do my best version of that, is this. As Ronald Coase wrote, basically, all market failures are about externalities. The idea that market participants don't bear the full costs of their behavior and sometimes don't reap the full benefits of their behavior. Now, in this case, it may be, it's possible that that market participants in the chip sector aren't considering the full risks that the United States can face, for example, geopolitical risk. That's conceivable, right? The problem is, from the moment you perceive that and you say, well, maybe markets aren't behaving optimally, you face a second, in many ways more important risk, which is the government is going to act and governments can fail too. It's not just markets that can fail. And in this case, like, the list of potential failures is actually quite long, right? You have white elephants where the government spends a lot of money on things that are useless. You have a risk of rent seeking. More and more we're getting to, we seem to have reached a point where the solution to every problem is just throwing money at it. And firms are going to perceive that and are going to spend a lot of money trying to be the recipients of those government grants. We have interventions that distort competition. We have interventions that can shift the direction of R&D potentially to suboptimal sectors. And even this, like, you have all of this is on the assumption that there is actually a market failure. And that is not entirely clear. There's a very long literature, some of which Milton cited, for example, with Alan Ostrom or Liebowitz and Margolis, just saying, well, there's this history of perceived market failures turning out to actually not be market failures at all. So I guess the big point is there can be a case for industrial policy, but there are also risks. And the question I think we need to ask is whether what we're doing now in the chip sector, whether it is good or bad industrial policy. I don't know if you want me to go into details about what I think is.
So hold right there, because George, I want to get you into this conversation. By the way, in 2006, Intel passed on the iPhone. So they didn't seem to have a market failure. They're still doing really well as a company, but they certainly passed on a good opportunity. So George, you've recently had a piece on this that talked about, are we in a situation where we will get to the national security challenges that come along with this as well. If we start to cleave down on China, do we put ourselves in a precarious position, since as we all raised our hands earlier and said we had an iPhone or an Android or a bunch of devices in front of us that have a chip? Is that going to be a problem? And you and I had a good discussion about kind of the secret sauce element of this. So let's talk about that.
Well, I guess there are many directions, many threads in that question. I would start by saying I think the headline concern that has driven a lot of this interest in chip industrial policy for the chip industry is, will China be capable of taking over the leadership in the industry technologically? And my view is they're nowhere near close to that, and probably it's not something that they can pull off anytime, certainly with their current approach, which is very much the sort of top-down Soviet throw money at it as though it were a matter of steel production or coal production or some other sort of highly commoditized brute force industrial policy of the past. That's not going to work. It hasn't worked for them. It isn't working. So I don't think the headline concern that we might lose technological leadership is real. On the other hand, China is a huge consumer of semiconductor products in their electronics industry. They import 90% or something like that of the chips that they use. Supposedly it's a larger dollar amount than their energy import bill. And what that reflects is certainly a vulnerability that China has, but it also reflects a codependency that a lot of US companies have developed over the past 2 decades, where they are selling an awful lot of their revenue is coming from China. And any abrupt shift in that, or abrupt decoupling, whatever you want to call it, is going to be a disruption for those companies. Qualcomm is probably a good example. They have something like 2/3 of their current revenue is coming from China. So if there is a crackdown on the ability to export chip products of a certain type to China, that it's going to impact companies like Qualcomm, NVIDIA, AMD pretty significantly. So there's a codependency that's developed, and it's going to take a while to work out of that. I'm not sure that the CHIPS Act is really going to address that in any direct way. It's not a manufacturing codependency. That's my point. It's a market codependency, a customer dependency.
Which brings us to another element in this, which is the labor market. So one of the gentlemen I was hoping was be able to join us was he's in Sweden, but Carl has written a lot about how part of the challenge on this is the labor market. It actually goes to the long tail of education. The software developers basically get near instant gratification and a lot of cash for doing what they do. To have somebody want to train in the hardware that it takes for semiconductors, it takes a good 10 years of engineering training and a very strong dedication for not as much money as you'd make if you're a software developer. So that is an element of the change that we have to look into this. And part of this is it brings a lot of uncertainty into a market that we haven't had that recently, as well as we now have US political interfering in the market with its entities list. So I know, Dirk, you write a lot about the challenges of uncertainty and what it does to a market. How do you put all this into play?
Well,
I mean, you have all these. Yeah. I mean, we have a lot of. So we've had a supply chain management shortage. during COVID, everybody all of a sudden found out that there were chips in their cars. I don't know how they were not knowing that. My stepmother actually walked out one morning and said, you were saying something about chips. And I said, yeah, there's this supply chain shortage. I was on a conference call. And then she came home later that afternoon. I go, how was your golf game, man? She goes, I bought a car. I was like, what? She goes, well, you said they're not going to have them anymore. And I was like, so you get certain points where people pay attention to this stuff or they don't. So I think that the whole idea of like, the relative uncertainty and how you see people like you react to it, obviously there's elements to this industrial policy that have.
Yeah. I see where you're going. So, I mean, there's a really big informational problem for governments acting here, which I think your observation goes to, which is, well, you say there is, for example, you say there's a shortage. Well, what is a chip shortage? How do you know what sort of the optimal level of chips on the market is? And this is sort of the really broad problem that governments are going to face, right? They need to figure out where the market may be working in a non-optimal way and find an intervention that improves that. That's really difficult. I think the starting point to sort of improving things, if you're the government, is to actually point out the problem. And I think that the CHIPS Act does a really poor job in that respect, right? You can sort of think of the CHIPS Act as, on the one hand, boosting the American semiconductor industry, and then ensuring the United States remains a tech leader in the future. The second of those two sort of objectives is way broader than the first, and I don't know how you measure that and how you act on that. I think even more broadly, even these two parts conflate many, many conflicting goals, making the industry more resilient, solving shortages, trying to make sure that you are at the cutting edge of that industry in the future. So you have these many conflicting goals, and then you're saying, well, we need to find a solution to that. And I think that is incredibly difficult, and it's all the more difficult when your goals are just so broad. Like, I could maybe illustrate this. One good case of industrial policy, a recent case of industrial policy that I don't think we've talked about right up to now, is actually COVID vaccines, right? That is a fantastic example of something we thought was impossible. The government perceiving a problem, right? We need COVID vaccines really quickly. We will put money into manufacturing. We'll pre-order vaccines and we'll fast track their approval. Like, it's a very contained problem and a relatively easy solution, and a good sense that markets weren't going to reach the right outcome by themselves. I think none of that is present here with the CHIPS Act. And so it's kind of going to be pot luck whether you achieve meaningful success here or whether the CHIPS Act fails to deliver.
Just a quick, since I know we keep referring to this U.S. legislation, the CHIPS Act, I think, is $68 billion, which when they came out, it was an astronomical number 3 or 4 years ago. And in the last year, I think we've spent like, I don't know how much more than that. I mean, it seems like a drop in the bucket compared to things like what we've spent on COVID spending. And a great moment of irony in U.S. politics. The person who will probably benefit the most from this bill is for a semiconductor plant in Texas for Samsung, and he voted against it. But yet he's still going to get, all this funding that comes into his area. So, George, you've mentioned that you don't think the CHIPS Act will actually enhance this, or could we have done without it? Do you think the market eventually, if these companies wanted to have their ability to reshore in the United States, did they need this government dollars to do that?
They don't. The amount of funding that the private sector is queuing up to spend in the next 10 years is something like 20 times the amount of the CHIPS Act subsidies for manufacturing, which, as I read the bill, it's $39 billion that are set for actual subsidies, and the remaining portions are set for other types of institution building activities in the government. But the private sector, if you look at what Intel and Samsung and Micron and AMD and TSMC and the rest of them have announced they plan to spend, and we're just talking about the fabrication piece here, not the other aspects of the ecosystem. It's close to $1 trillion over the next 10 to 15 years that they've announced. Now, will they queue all that up and spend it? It's not quite the same as a government appropriation, but it shows you that the CHIPS Act, in terms of its financial impact, is probably been overstated. And I agree that if you look at the details of what the CHIPS Act is calling for, it's not very well thought out. They kind of throw a couple of general technology objectives out there that are actually probably not correct, not the right ones that the industry would want to say are the measure of technological leadership. And besides that, it's kind of the helicopter money for the chips industry. They just are going to drop a lot of dollars on people that already have a lot of dollars, and why won't they take a few more? They're happy to take it. So nobody's going to object to getting some government largesse, but whether it's going to have an effect, a qualitative effect, I'm also doubtful. Let me just say, I think the COVID case is a very interesting one, by the way, because as I see it, what they did right, probably by accident, was they didn't try to specify the technology. They just said, we're going to remove the risk from the situation. We're going to remove the risk of a vaccine manufacturer making a commitment to manufacturing earlier than they normally would, because they want to validate, go through all the hoops of the Federal Drug Administration and so forth. Well, the Operation Warp Speed, I guess they called it, really just said, we're going to remove those risks from the table and allow the technology to follow its own path. And probably by accident or by good luck, that seems to have worked pretty well. I want to just say quickly, there is another, in the pharmaceutical world, there's another example of I think a successful policy that is relevant, in my opinion, here, which is the Orphan Drug Act in the United States. There are a lot of illnesses, apparently, a lot of conditions where there aren't large segments of the population. There aren't large markets attached to the development of drugs for certain kinds of conditions. And because of that, there is a kind of market failure inherent in the pharmaceutical industry, where companies are going to focus on the big markets. They're going to focus on Alzheimer's. They're going to focus on cholesterol reduction. They're going to focus on the huge markets and not on the small niches that are very important for the people that happen to be in those small niches. That analogy also holds true in the semiconductor world. There are enormous core markets like the cell phone and, let's call it, the cutting edge chips that are driving the digital infrastructure. But there are lots of smaller niches in the market. My favorite example at the moment is in the military, in the defense world, where the volumes are very small. And the Stinger anti-aircraft missile that everybody knows about, now the design of that can't be built anymore because in its current design, because it was built around chips that are no longer manufactured. And it's going to have to be redesigned for new production of that military product. It's going to have to be redesigned, which isn't the end of the world, but it shows you that there's an inherent, let's say, imbalance in the market in favor of the very, very large market segments, and not so much attention given to some of the smaller ones that turn out to be critical. When a car has 500 chips in it, one or two of them can be critical, even if they're not cutting edge.
And thank you for the correction. The 68 billion was one of 12 programs we're spending on broadband funding. So see, 37 billion just got dwarfed immediately. Did you have some follow-up thoughts? Here's your taking notes order.
Yeah, I mean, I think one of the as George suggested, one of the successes of the COVID vaccine policy was just a pre-commitment to buy doses. And it's funny because here in the CHIPS Act example, in the broader CHIPS example, it could be in the European Union, one of the problems is that when you have conflicting goals, this becomes difficult, right? Because if the CHIPS Act was only about boosting US production of chips, you'd say, well, great idea. Pre-commit to buying some chips, it would be, and you can be relatively technologically neutral about it. The problem is there's a second conflicting goal, which is at the same time, you're trying to solve a chip shortage. And we know what's going to happen if you increase sort of demand on the market, right? So I think it's just another example of pursuing different and sometimes incompatible goals is really one of the things that can very easily undermine industrial policy. And I fear it may be a problem here. I think there's a second aspect that I think is important, which is at least some of the risks here. I think recent events in Ukraine suggest we shouldn't take them lightly. Before the conflict in Ukraine, there were many people in the European Union who were saying, look, Russia and Europe are very codependent on Russian gas. That should probably be enough to avoid a conflict. That was not true. And I think there is, to some extent, the same thing here, where we realize that the chip industry today is very reliant on Taiwan, and that's a risk. I think this may be naive. Like, this is the problem. This is the trap, is that no one has perfect information. So maybe I am wrong here, but I think that is one of the bigger risks in this space. I think it would have been probably better for the legislation to be more geared towards that specific risk, though even that I say with trepidation, because
no, I think the national security element drove this from the beginning, right? I mean, and the whole idea that somebody was going to actually maybe reshore jobs in the United States, or perhaps, you know, more in Europe, was the secondary effect. That it was much more of the concern about, you know, where do we stand? And it really was, I mean, it's interesting because DARPA was a major part of the creation of the semiconductor industry. And it was the guys, you know, the Department of Defense who were like, finally looked at a map. I don't know if they got it out and said, wait a minute, look at all these things going on over here in Asia. And it's really getting to be a hotbed over there. So I think the idea of whether or not somebody is making money on the chips is really, you know, not the priority element. But it was an imbalanced conversation that we had during all that. Though I did love towards the very end when the CHIPS Act got caught up in a whole bunch of other political things that had nothing to do with chips, that the Intel marketing team was smart enough to like start doing media saying they were looking at places in Europe to start, you know, doing fabs. And the Americans took notice and they finally passed the bill. Like they're like, whoa, wait a minute. I mean, we started this whole thing and now we might actually lose the one thing that we wanted, which was money back in the United States. So that's a really key component. Yes, questions, go ahead.
Yes, about the answers. So that's online.
George, can you hear?
I think so.
You have to repeat it, right? Okay, thank you.
Okay. Two questions basically. The first one is that what Dirk is saying, that we're moving chips factories to the US because of Taiwan. Consequently, that Taiwan becomes less relevant. So there's no necessity to protect it anymore, really, if that happens. The second one is in the Netherlands. You mentioned ASML, and I think I never thought about this question before until somewhere this summer. This is absolutely critical infrastructure. Are we protecting it in any way? Is there a defense line now around Eindhoven and Veldhoven to protect it from incoming bombs? Because if this accelerates, this is going to be one of the first targets. So are we doing anything on this? And there's nobody who's going to have an answer. But is there something happening like that in the US or elsewhere that you know?
So I'm with you. 2 days ago, I didn't know much about it until I started really, I found this one little thing and I said, I kind of started looking at it, and they do have 60 other locations. And one of them is in Austin, Texas, and they're around the globe, but they really do the actual machines that they send over to Southeast Asia to create these things are the design of them are created here, as well as a lot of the physical entity elements of it. So that's a very good question. I mean, maybe we aren't looking broad enough at the national security element.
As far as I can tell, at least, the machines are such that if you don't have the engineering know-how to go with them, maintaining them and using them, I'm led to believe is basically impossible. So there is a sense that if there were problems, I don't know what would happen to the actual machines, but the worst case scenario is that they would be useless without Western knowledge. But I say that with trepidation. I am not an engineer.
Well, George, you've alluded to this in one of your recent articles where you talk about, there's just certain elements, and unless you have the right minds, the engineering people involved, you cannot engage to the next level if you just wanted to start making this from ground zero.
Yeah, I think Dirk is absolutely right. This is, you both made the point. This is an economic, techno-economic process that is so deep and intense in terms of the know-how that surrounds the formal technology. It's not about the patents as much as it is about the decades of experience of the people that know how to operate these machines, that work with the customers very, very closely. Apple and TSMC work very, very closely to obtain the products that Apple needs, for example, and that process is replicated, and that's why the idea that China, for example, could quote unquote take over Taiwan and somehow acquire this capability is not real. The head of TSMC has said that their facilities would become inoperable if anything happened like that. And I don't think he was suggesting sabotage. I think he was suggesting that you remove one or two key people from the picture who know how to operate. You remove the customers from the picture, who are working very closely in the design and the fabrication. This is, and to the gentleman who asked the question from the audience, I don't have any view on whether there's a defense ring in the appropriate part of the Netherlands to protect some of the assets there. And I guess we have to remind ourselves that that type of threat is still out there. I don't really have a comment about that, except to say that if it were in the interests of someone to try to disrupt the semiconductor ecosystem, it would be very easy to do it. There are so many critical points in the network. It's a really incredibly complex ecosystem. ASML, for example, themselves have something like 5,000 suppliers, some of which are sole sourced to them. So, a bad actor that wanted to physically disrupt the system could do it, I think, without too much trouble. And I don't know what the world can do about that, other than try to make sure that the bad actors stay in their bottle.
Maybe it's hiding in plain sight. Yes. The person who's getting a PhD in.
Yeah, I'm starting a PhD on semiconductors at UCL in London. So on the helicopter money, I think it's an interesting parallel. So on one hand, you have if I understand the CHIPS Act, a lot of subsidies for companies who would want to invest in new plants. And then you mentioned the parallel with the vaccine, the COVID vaccines, where you do the opposite. You work post innovation and you cover the risk of the supply chain. So you procure vaccine in advance. Wouldn't that have been a better move, actually, which is something that we do a lot in Europe, procure or secure the procurement of chips. So the US would have ordered for the military, for the energy companies, certain amount of chips in advance. That would have been maybe more virtuous. You would probably widen the shortage of chips in the process. I'm not sure it's actually valid, but I don't think the helicopter money works if I can follow your thread. The second question would be about the trade war, because it's not very clear if the CHIPS Act includes the restrictions on exporting chips. It's probably a very bad move to do so, because you only accelerate the innovation cycle in China. Exactly what happened with telecom and the network equipment providers. No 5G networks are built in the US on actual American technology. It's all Ericsson, Nokia, or Samsung. So wouldn't be the risk to actually accelerate the lead of losing the lead from the US and accelerating it from the Chinese perspective?
I have lots of ideas, but I'll let these guys go first. George, did you want to comment on did you hear that?
Yes, I did. At least the second question. I don't think there's a risk that I'm not saying that I think there's only good things that flow from the export restrictions, but I don't think that the risk that suddenly China is going to decide, okay, they're going to do it themselves and become a power in the industry. They've been trying to do that for decades now. And it's not working for them for reasons that have to do with their approach and their system. If you look at China generally, they're coming at this from the perspective of what I would call the Soviet model. You know, they're going to distribute a lot of funds top down and try to direct the industry to come into being, and it just hasn't worked. And most of so I don't think that is the risk factor here. I think the impact of the export restrictions, the more serious one, is going to be on the suppliers in the West who are, as I said, dependent upon or codependent on the customer base that they've built up in China, and weaning themselves away from that. And you see they're beginning to try to think how to do that. Apple is thinking how they can move their production away from China. Even TSMC is thinking how they can move their production away from China. That's, I think, going to be the more disruptive impact rather than seeing a sudden upsurge in Chinese domestic capabilities to match the technological side of the equation. I just don't think they're going to be able to do it with their current model.
Yeah, I think like the way I think of the big picture here is you may be familiar with the short novel I, Pencil, where the argument is basically no one person in the world could actually make a simple pencil. I think that argument applies even more with chips. And there's good news and bad news in that. The good news is this is such a specialized industry, it seems unlikely that sort of China could go rogue and just because we've cut them out, sort of replicate that whole industry itself. And as George mentioned, they've been trying to do that. And from what I can gather, it hasn't been very successful. Now, the bad news, on the other hand, is that it makes it very difficult, I think, to wean ourselves off of Taiwan and existing sort of nodes in the network. I think that's part of what the CHIPS Act is trying to achieve. I don't know if it will be successful.
TSMC is smart enough to know they already have a facility in Arizona, and they're working on that as well. So they are looking to diversify. But the other point that George kind of was alluding to is that the big tech is changing the market itself in the cycle of evolution. So for those of you, and a lot of you have been in the tech space for a long time, it used to be you would update what you did on the back of what your partners did. So Cisco routers came out, and on, let's say, an 18-month cycle. So you would work around the router cycle to create the next thing that was going on. Well, there's a certain point where the Meta, Facebook, Google, Apple all started to realize that cycle wasn't working for them. And they have actually done a very good job of disrupting this and taking component parts of this inside. So the most recent iPhone actually has, they changed their structure around what chips they're using, and they have certain component parts that are very specialized that they have only internally. And they finally kind of got to the point where they said, well, we're just going to have to start building this stuff ourselves because the actual marketplace is not moving at the speed that we need. And so it's been interesting to see how that has actually had this huge reverberation with like Corning, companies like that are used to doing things at a different cycle. And then on top of that, with COVID, we saw, like you were talking about, basically, could they just hoard chips for what they needed? If you have a certain size chip and it's a good generic chip, the answer would be yes. And actually, Broadcom has done a white paper that said, they went to the government and said, could we kind of reconfigure how some of these industries are using these chips, because we think we could solve part of this supply chain management, but we need kind of a thumb on the scale. And the government didn't seem so interested in doing that at the point. But GM actually had to close some of their facilities for almost a month because they didn't have the chips that they needed for the cars that they wanted to create.
Yeah, I just want to go back to the export controls. I'm fascinated by this. I think it just sounds to me like a complete disaster in terms of the overall digital economy. What do we think we're accomplishing? I mean, do we think that we're going to like turn China back to 1978 or something? What are we going to, I mean, clearly, on the one hand, we're saying we want to promote the chip industry. On the other hand, we're saying we're not going to let them sell to the world's biggest market to the highest levels of demand. What are we doing here? Isn't that working at cross purposes? And is the fear of China that they will buy our chips and learn how to make them, or that they will be able to make products that do things that we don't want them to do? Or is it that they, we're just punishing them and trying to stop them from economically developing at all?
Well, I think the stated goal is to prevent military access by the military in China to the most advanced types of technologies that come out of the U.S. industry. So if you look at NVIDIA, for example, it's not their whole product line that's been constrained here. It's only the very top end, so-called top end. Now, does the Export Control Authority have the ability to identify exactly what those critical products are? I'm not sure. I would say they're going to be perfect on that, but that's as I understand it, that's what the goal is. And I'm not defending that goal. I'm just trying to explain what I think they're up to. And the test run of all this that we've already gone through is with Huawei. If you go back a couple of years, Huawei was essentially had become the market leader in the cellular industry, in the 5G industry, and both the infrastructure and the handset side. And the application of this type of technology restriction on them has essentially crippled them, even in China, even in their position as a domestic supplier in China has been greatly diminished. And so I think there's a demonstration effect there that some people have glommed onto, and they're going to hope that they can apply the same kind of pressure in a broader way to the Chinese, and focusing particularly, as I said, on dual use military concerns, but certainly with an undercurrent of let's bring them to whatever the right metaphor would be. Let's cripple the Chinese capability to compete in this technology.
I concur with your sentiment on that, but I started to look into this, and the first round of the entity list in 2019 made entire product lines impossible for Huawei to produce at a certain level. So I think that they took that, and then we had the announcement on October 7th, and the Undersecretary of Commerce and Industry and Security said that their goal was to prevent Chinese military intelligence and security services from acquiring sensitive technologies within their military applications. So that's their stated goal. The interesting knock-on effects, I think we're still looking to see. We'll see how that plays out. Anything you want to add to that?
Yeah, I think on the one hand, your point is well taken that people often assume that export controls are costless, and obviously that is not the case. It is a costly policy, and the question here is whether we're willing to pay those costs in order to reduce the threat from China. And does it achieve that goal? I think it's obviously very hard to tell whether it will be the case. The only point of sort of data point I can think of is that recent events do suggest that industries develop around certain chips, and that it's not easy to switch from one model to another. So maybe it is the case that that preventing certain exports will be more harmful to China, so to speak, than it is harmful to the United States. But the technical expertise there is really beyond my abilities.
May I add? Oh, all right.
Sure. Yeah.
I just add real quick. I think also you have to take into account the signaling component here of this type of move, and that applies to the CHIPS Act as well. I'm inclined to the view that the subsidies that the CHIPS Act is going to dole out, for example, aren't going to have much of an impact on the industry direction that it would be taking anyway. But the fact that the CHIPS Act has become so central in the political discussion in the US, and that here we are talking about it all we're talking about semiconductor and geopolitical risk in the same sentence. That is going to have a big effect, I think, on the industry itself and the decisions that the private sector is going to be making, which, you know, a couple of years ago, they wouldn't have been thinking about the geopolitical issues in their decisions about where to put the next plant or how to develop the next product line. And I think they are going to be thinking about that. They are thinking about that much more because the signaling effect is very powerful of these measures.
This is a blended quote that things I've read lately. It said, we have been focusing on social media, not the silicon wafers when we think about tech. Both Washington and Beijing understand the power behind controlling the supply chain for compute power. So I think that's the key there. And then your question over here.
Yeah, I have a question with respect to the framing of the conversation, actually, maybe the complexity of coming up with the right kind of evaluative framework for dealing with these interventions. You know, going back also to the presentation that Milton gave, so much is actually kind of like converging in terms of like the national security policy, and we have like innovation policy, economic policy,
Trade sanctions,
trade policy, and like domestic and the international dimensions of all of this. And so what I find maybe the most complex is that we have like all these kind of maybe classic approaches to look at these particular kind of policy areas, but things are very much blended together. Like maybe just as an example, like the way that you know, like economic considerations are like very heavily featuring in national security considerations. So like so economic kind of competitiveness, but it goes in many directions. So and connected to that, maybe you know, like it feels to me that like industrial policy, there's like it's something industrial policy if it's like explicitly stated to be industrial policy, or you know, is this also a matter of like just looking objectively at what a particular policy is doing? Because like coming from Europe, I think in a lot of like digital policy areas, you know, Europe is not being explicit about having industrial policy motivation, but typically you can discover them if you look carefully at the politics. So I mean, I understand these are complicated points and questions, but I'm particularly interested in how to evaluate all of this.
Do you want to add to that? Yeah.
My question actually is related to that. I mean, obviously, it is obviously is not a purely industry policy as we have been discussed so far. You know, it's a very geopolitical implicated. So my question actually is related to sorry,
Dirk,
question, because you talk about there's a conflicting goals. One is both the chip industry. Okay, this is we can say is a political goals. The other one is the shortage of the chips. But this is a more economical goals. Actually, I'm wondering, why do you think this is a conflicting goals? Because basically you said because the shortage, because it's reliant on Taiwan, and to be honest, Taiwan is very close alliance to America, you know, and there's rumors there's a military base, you know, built up in Taiwan. So I do not see why you think this is a conflicting goal. What is the political risk there? You know, if it is, even it is reliant on Taiwan. So this is my first question. The second question actually is related to you talk about the best industry policy is a co-investment, you know, co-investment. So it's not like just George said, it's a state-imposed policy, is rather than co-investment. So I want to see what is the difference between the you propose like a co-investment and George said currently the policy, that the industry policy is state-imposed in China. Because I do not see it is a state-imposed policy in China, because they already learned from the past failure. You know, the recent case probably you heard about is the arrest, the head of one of the most important seed fund in China, which the seed fund is help to boost the industry, the chip industry, but it failed. So the rest of all this top management. So for me, it's not entirely, state imposed. So I want to see the difference between co-investment and state imposed policy. Thank you.
Either of you want to take that on? It's a lot.
Do we want to start with the first question or the second, or how
It's
do
up to
we?
you. You get an answer.
I think so. On the first question, I think there is one potential answer, which is this: if you're faced with many different goals, it could be that one answer or a big part of the answer is just keep doing across the board things that work well. I think the US today is a tech leader. It's a leader in universities. It has a working and by many accounts and mine, a very good IP system. Keep doing that. That is extremely important. And that is not a given. It seems more so now that US policymakers are interested in sort of maintaining the United States IP system, but there have been many high-profile examples of US policymakers saying, well, actually, US tech firms shouldn't be seeking injunctions against firms that are importing chips from other countries. So I think that's one starting point. Same thing for applying, say, antitrust laws in a sort of non-political way. That is another very good solution to keep your economy competitive and stay in front of the race. So that's, I don't know. George,
I feel like that was a good, like your university professor counseling. Keep doing what you do well.
Yeah. Well,
did you want to take the second one, or maybe you can, George, did you want to comment on that?
Well, if I grasp the thrust of the question, I guess my answer is that I think industrial policy is probably never, but certainly in the American context, is never a coherent, consistent policy across the board. It's a patchwork of initiatives that come from either philosophical positions in the political spectrum or from economic positions of interest in the industry. I think if you look for a sense of consistency in industrial policy in the United States, at least, you don't find it, but you certainly find a lot of instances of the government being either entering on its own or being drawn into putting its finger on the market, the scales in the market to achieve particular aims. And I'm skeptical that they ever really are that effective at achieving their stated aims, but they sometimes, and I think that's what's happened in the CHIPS Act case, they do get the attention of the industry and of the public on certain issues and bring those issues into the calculus of economic decision making that the market is already going to be pursuing, but that might not have paid as much attention to. And I think that's, every company in the electronic industry today, I'm prepared to say, quite forcefully, is developing a Taiwan hedge or a China hedge policy. How are they going to deal with the risks? How are they going to de-risk their exposure to China as a source, as a customer? They're all, again, thinking about that today, and they weren't a couple of years ago.
No.
I just can't let you escape without addressing the European CHIPS Act. We are in Europe after all, and they had their own CHIPS Act, and I just wondered if either you or your panelists had any perspective on what that is. I mean, it's after the American moves, I have to confess, it sounds kind of like a Me Too thing, but I don't know I don't know that much about it.
I'm still confused now. My European colleague over here, because I always feel like in Europe, once we pass something in the United States, then we start to act on it. And here, I feel like they think about it a lot, and then they pass something and they think about it more. So I'm never sure when the actual action happens. But that's just my naivete about how European policy and politics works. So, do you want to educate me?
I have to confess, I haven't been following the European aspect of this debate very closely, so I don't. I mean,
So moderator's prerogative is I've been ruminating on IPv6 ever since this came up yesterday, is an area where I could see industrial policy becoming in this space, and that you have a technical need that we thought was going to come faster. We thought we were going to need much more compute space, and we were going to need to change the dynamic of our IP number system from 4 to 6. And then that happened to coincide with the 2008 crash of the market. And the thing is, you needed to convince a lot of companies who were using these computers that they needed to move away from their legacy computers into a new device. And they didn't necessarily feel like that was the best use of their capital at that point. If you go back and kind of look at that, I went back and looked at it in 2012 and said, why is it that we didn't move along? So when you mentioned yesterday that there's a possibility of this becoming an ITU issue, I was like, so what are they going to, like, they're going to tell people like, damn it, we're moving. These IPv4s are going to stop working, which is going to be a pretty tough thing to do when you don't actually hold the actual computers within your grasp. Not that I'm against it. I think that moving to IPv6 is actually the way of the future. We need to get there, but do we need the government to intervene to push, especially large corporations who are the major holder that needs to move forward in their legacies, computers to start taking bigger steps in this space?
Sorry, may I respond to that?
Sure, yeah.
So the resolution has been there for, I believe, 12
Yeah.
years, but I should check with my other colleague in that.
12's about right, yeah.
So it's not the first time it's been mentioned in the resolution. It's resolution 180, it's the ITUPP. Well, we have been talking about changing or transitioning to IPv6 for over 20 years now. And if the industry after 20 years still does not want to move towards IPv6, then, well, I do see that as a kind of failure of the industry. And to be slightly more specific or explicit on the resolution, it doesn't say that ITU is now going to enforce IPv6 or anything. It's just another encouragement to the industry to please adopt IPv6. And I think that's.
But the industry is adopting. I mean, the big ones are. See, that's the thing. It's that
it's not just an industry. It's the different sectors. Yeah,
the big company. We did a study on this. And the cloud providers are providing a bridge.
Mobile providers, cloud providers. They all have different demand for different types of addresses and amount of addresses. So,
and they're basically the networks that are growing fast are adopting IPv6.
But do you guys know if any one of you has their own website, or maybe the Internet Governance Project has a website, do you know if it runs on IPv6?
Yeah.
And we should be asking our network operators to and people behind it, please make sure that my website is IPv6.
But why does it need to?
Well, there's different aspects. One aspect is, for instance, that you may even think you're not running IPv6, but downstream you are.
Yeah, okay.
And if you don't take that into account and you have the website is secure, you need to know. So the fact that it's two next to each other does lead to disruptions, and abuse is being made. So awareness of that is the least thing that can happen.
But I think one of the things that we proved in our study is that we're going to have a mixed system for at least 20 more years. That's just a fact. You're not going to magically make legacy V4 disappear. You're not, and for many small providers, it just doesn't make sense, and it doesn't really make any difference because they don't need more addresses.
Well, maybe not. Maybe we don't need, or people here don't need more addresses, but if we want to connect the unconnected, they need IPv6 addresses, or they need IP addresses, and often don't have enough IPv4 addresses.
We'll talk about that offline. Marco is jumping up.
We're actually supposed to protocol. IPv6 was ready to roll in 1999, but then it would have.
I meant the kind of the rollout, the whole push, yeah.
But I think also, and I kind of heard you say, like, yeah, IPv4, and that's also where Milton is going. IPv4 isn't going away. IPv4 isn't going to be switched off or become unusable. That's really not the problem. The problem is that by sticking to IPv4, there you say, oh yeah, all the big ones do IPv6. Well, right now I'm carrying 2 phones and I've got my laptop here. None of this has IPv6 connectivity right here, right now. And by that, we force the 3 million or so unconnected people to go scavenge for IPv4 access, which they don't get because we're using all the others. Because after all, there are only 4 million addresses for about 8 billion people. So that's kind of the societal aspect. Now, to industrial policy, should that we force them or can we force them? Well, I do have large, and disclaimer, I work for government these days. I do have large network providers that say like, oh, if you want me to speed up IPv6, tell me to do so. Well, that's kind of the self-fulfilling prophecy there, but it will be the end of the multi-stakeholder model. And I think that's the critical part there, is that industry self-regulation means you sometimes also have to do the things that you might not want to do in order to save your system. Because once we start telling you to go IPv6, and a lot of people look at the ITU, but ITU isn't formed to set industrial policy. Certainly not on a local level, but also from a global perspective, all you get is recommendations. But yeah, once we start forcing and telling you to do IPv6, we'll probably have a long queue behind me of other people who say like, oh, but if you do IPv6, can you do this and that and that and that? And that undermines the whole model. And then that's what we keep trying to advocate to industry. You better just do it to save your own sort of liberal, self-regulating system. Because otherwise we will indeed force you, and then the list will be longer than just do IPv6. But
export controls for IPv4. Right?
So I've gone beyond the time. I just thought it was an interesting discussion, and in no way meant to just, I just highlighted it because I started thinking about it and I thought, well, is there some point where somebody has to push you? Well, you know, what's up next?
Shane, you're the only person who could hijack your own conversation.
Well, thank you all very much for listening to all of these. Thank you.